Okay, so here's a few examples if you weren't in class of doing the fusion practice. All right, so there's a couple typos that I had here. This number for LA for number 1, if it doesn't say 57 for you, change that to 57, okay? And then the other one is this one down here at the bottom. Number 5 should say 3 in front of those neutrons, okay? All right, so those are just a couple typos that I had. Okay, here we go. You ready? All right, so I'm going to do a couple examples. So now the first thing you're going to do is you're going to look at this reaction, and you're going to tell me, is it fission or fusion? Remember, fission is starting with one large one, and it splits into 2. Well, fusion is 2 small ones that combine into 1, okay? So if you look at here, if you look at my reactants, and really you can determine just from the reactants itself. Notice it's just one atom. So if there's one atom here in the reactants, most of the time this is going to be fission. And you can double check it and look over here. Oh yeah, it has a neutron that hits it, and then we have 2 smaller ones, okay? But then we have to make sure that our mass and our protons are conserved to meet that conservation of matter. Okay, so for uranium, it has a mass, that's the top number of 235, and it has 92 protons because its atomic number is 92. This neutron here on our reactants has a mass of 1 and 0 protons, and then for the totals, you're going to add all of this together. So you're just going to add 235 plus 1 gives me 236, and 92 plus 0 gives me 92. Good. Now that's what I should also get on the other side. My totals should match up. So let's take a look. So for here, our lithium, it has a mass of 145 and an atomic number of 57. Well, bromine has a mass of 88, protons, atomic number 35. Now this is where this gets a little tricky. There's 3 of them there. So instead of going, oh, there's 3 of them, so 1 plus 1 plus 1 is 3, we do, in math even, for repeated addition, we do multiplication. So we're going to do 3 times 1. So it's 3 times 1 equals a mass total of 3. Well, 3 times 0 is 0. Okay, and then again, you're going to add all those together. So if you add 145 plus 88 plus 3, you should get 236, which is true because it matches the mass from the reactant side. And then 57 plus 35 plus 0 will give you 92, which means that is a correct fission reaction because the mass is conserved as well as the matter. Okay, you're going to repeat that process here for number 2. Okay. All right, for number 3, 4, and 5, you're going to find the missing number. So this is really nice because I just gave you for these 3. Okay. I just gave you for these 3 missing the atomic number. Sorry, there shouldn't be a 3 there. I put it on the wrong one. Okay, there shouldn't. You're going to find that. And what you can do is once you've calculated that missing number, you can go back to the periodic table, and it should be the atomic number of the element that is listed here. All right, so let's go ahead and do it. So for uranium-235, it has a mass of 235, protons of 92. Neutrons, there's only 1 of them, so we have a mass of 1, protons of 0, which gives me, when I add them together, 236 and 92. Okay. Here, for tellurium, we have a mass of 137, protons of 52. For ZR97, it has a mass of 97. I don't know the atomic number. There are 2 neutrons here, so 2 times 1 gives me 2, and 2 times 0 gives me 0. Now, 137 plus 97 plus 2 should get me 236. Okay, and it does. Now, this one I already know because it's conserved, the total has to be 92. And since I usually add these together to get 92, I need to go backwards, which means I need to do the opposite of addition, which is subtraction. So to find this one, I'm going to do 92 minus 0 minus 52. And when I do that, I should get 40. And that should be my missing one. And you can check it again. 52 plus 40 should give me 92. Okay? So the atomic number of ZR is 40. And you can double check that on your periodic table. If you look up atomic number 40, it is ZR. Okay? And then determine if this is a fission or fusion again. Notice this is just one large atom getting hit by a neutron, splitting into two. So that is a fission. Okay? And you're going to repeat that process for 4 and 5. Make sure you put a 3 in front of that bottom one there. Okay? All right. Once you kind of practice a little bit, you're going to turn it over. And now we're going to practice finding the missing numbers again. So the first two, again, the first one you're going to find the missing atomic number, and you can, I left you some space here to do your calculations, okay? And then you have put your missing number here and then tell me if it's fission or fusion. Here you're going to calculate the missing mass, okay? Now in the bottom 4, you're going to actually now not just calculate one missing number, but a whole entire element. So you're going to have to figure out what that entire isotope is, okay? So I'm going to do the first one as an example for you, okay? And you can do it in any organizations you want. You just have to figure out what works for you. So I'm going to do it this way, where I'm going to write reactants, and I'm going to write mass equals, I'm going to calculate the mass for my reactants. So 235 plus 1 gives me 236. For my protons, it's going to be 92 plus 0 equals 92. So that's what I'm starting with, and that's what should equal here in my product side. Okay, so now I know my mass is going to equal a blank plus 95 plus 3 times 1 gives me 3, and it's going to equal 236, but I have to find out what that missing one. So I'm going to do the opposite. So I'm going to subtract. So I'm just going to do my work up here. So 236 minus 95 minus 3 should get you 138. So that is my missing mass. And I can put that up there, 138. Okay? Then I'm going to figure out my protons. So right now what I have is blank plus 38 plus 3 times 0 is 0, and it's got to equal 92. So I'm going to do my math here. I'm going to do the opposite of addition, which is subtraction. So 92 minus 0 minus 38. Okay, and when you do that, you should get 54. So my missing atomic number that has to go there is 54. So I'm going to put 54 here. Then to find my symbol, I'm going to look, of course, on my periodic table. So I'm going to look up atomic number 54. So let's go find it. There it is. It's right there. And its number 54 is xenon, Xe. And of course, it's 2 letters. So the first one is capital. The second one is lowercase. So that is my missing isotope. Okay, and you can write it 2 different ways here. You can write it, okay, Xe, remember 138, or you can write it as its isotope, or the nuclear isotope notation, okay? And then determine, is this fission or fusion? Of course, now again, we're going to start with the large one with the neutron in it, splitting into 2, so this would be fission. Okay, hopefully that gets you started. If you have any questions, let me know.